Okay, here's another 17C video, mostly for the students in Carlson's class. I believe he is doing this thing where you're proving limits. So here is one example of the idea. So we're going to prove the limit as xy approaches 0, 0 of 2x squared plus y squared equals 0. And we can easily see that that's true, right? If you plug in 0 for x, 0 for y, you get 0. Here is the idea behind this proof. We're going to find a small number delta. That's what that is, greater than 0, positive delta, so that for any other small number, epsilon, which is also positive, the following is true. And this is kind of the part we have to find some understanding. If the square root of x minus x naught squared plus y minus y naught squared is less than delta, all this says here is that the distance between x, y, and x naught, y naught is less than delta. Right, that's all we're saying, right? Because this is the distance formula for the distance between x, y, and x naught, y naught. And in this problem, this is our x naught, 0, 0 is our x naught, y naught. So what we're really saying with this is the distance between any point x, y, and the point 0, 0 has to be less than delta, meaning if you think about it graphically, if your x naught, y naught is 0, 0, we have to be within a circle of radius delta. So if we're really close to 0, 0, right, that's what we're saying, we're doing a limit, right? We're doing the limit as x, y gets close to 0, 0, means we have to be super close to 0, 0. Then the function value should be really, really close to 0 as well. So if you look at this function here, and I'm going to try and draw it, because I kind of know how to draw it. It's a paraboloid. It kind of looks like, we'll try and do a good job of drawing it, James. Oh, I should have pulled up Desmo so you guys could see the cool thing I found. Kind of does this deal. And you can kind of see, hopefully, that if my, and I'm going to try and draw it in the plane here. So if my x, y values are within this circle in the plane, if I project that up to like my function here, then my function values have to be within some kind of, oh, there's a word I can't find right now. They have to be close enough to the y value. So basically, if my x and y point are really, really close to the origin on the plane, then my z value is going to get lower and lower, being close to the z value of 0. Here in this example, everything is kind of 0 because of it. So all this part is saying over here, let's do a different color just so you can kind of differentiate here. This is just saying that if the distance between x and y, if the distance between x, y, and x naught, y naught is small, then the distance between, this is the distance between the function and the limit value also has to be small. Okay, is there anything else I want to say about that? No, not really. This is just saying z is close to L. This is just saying x, y is close to x naught, y naught. So as our x, y get closer and closer to what they're approaching, the z values of the function values get closer and closer to the limit. That's the whole idea. All right, so to prove this, here's what we're going to do. So we're going to, and I will fully admit I'm totally stealing from Grant's notes on the old 17C. If you look at his webpage, he's got lots of good examples. So our job is to find delta. What we're going to do is we're going to start with the other condition. So we're going to manipulate the thing we want to be true. We want it to be true that the absolute value of f of x, y minus the limit is less than epsilon. Our f of x, y is just the function we're working with, so that's the absolute value of 2x squared plus y squared to be minus 0, right? I'm not, I don't like the minus 0. To be less than epsilon. Meaning we want the difference between our function and 0 to be small. So how are we going to make this work? Well, here's what we want to do. I'm going to go back to this side. Our job is to kind of make this expression show up. So if you look at this here, if x naught is 0 and y naught is 0, we're really trying to get something like the square root of x squared plus y squared, because we know that that is less than delta. Or we're going to make it less than delta. Okay, so here's what I've got. I've got 2x squared plus y squared. And I want kind of just x squared plus y squared. So here's what I'm going to do. I'm going to say that 2x squared plus y squared is less than 2x squared plus 2y squared. That seems legit. And I can factor out the 2. This is 2 times x squared plus y squared. And I'm going to make that less than epsilon. So if this is less than epsilon, then certainly the thing I need to be less than epsilon is less than epsilon. All right, but now that I've got x squared plus y squared, I can use the fact that I need the square root of x squared plus y squared to be less than delta. So what I'm going to do is I'm going to manipulate this now to get the square root of x squared plus y squared all by itself. So I'm going to divide both sides by 2. And hopefully I'm doing this right. Yes. And then I'm going to say that the square root of x squared plus y squared is less than the square root of epsilon over 2. Exactly. So what that means is, since I know I'm going to say the square root of x squared plus y squared needs to be less than some delta, we're going to let delta equal the square root of epsilon over 2. So here's what we then get to say. This is where you kind of have to, it's a little bit of work depending on what they want you to do exactly. So this might be good enough, but often people say, okay, so now we say, let delta, so this is depends on what your teacher wants. So let delta equal the square root of epsilon over 2. Then, the square root of x squared plus y squared less than delta implies that the square root of x squared plus y squared is less than the square root of epsilon over 2. And you can either show all the work, or you can just jump to saying, oh, well, that means what I want. That that's less than that. So at the very end, you could say, I'm going to show the intermediate work, but you could also just jump to say, that implies, and we use this kind of double arrow to say implies that the thing we want, 2x squared plus y squared, in absolute value, minus 0 if you want to be real specific, is less than epsilon. That's what we're going to get to. And we're really just going to use the work we did back here. So I'm going to square both sides. So x squared plus y squared is less than epsilon over 2. Multiply both sides by 2. So then 2x squared plus y squared, 2y squared is less than epsilon. But if 2x squared plus 2y squared is less than epsilon, then certainly something smaller than this is also less than epsilon. So you can say that 2x squared plus 1y squared, which is smaller than that, is also definitely less than epsilon. But that's exactly what we wanted. That takes us to right there. So that's kind of the idea. I hope this helps. I know it's not the most natural kind of idea to comprehend. Let me know if you want me to do another example, and I will. All right, I'll see you guys later.